Picture this. You're flying in an environment so relentlessly hostile that the air outside your window is literally burning at 10,000 Kelvin. When you hit speeds over Mach 15, the sheer friction and mechanical compression generate heat so intense that traditional aircraft metals don't just melt, they vaporize. This right here is the ultimate barrier in aviation. It's a physical limit where everything we know about conventional aerodynamics just completely falls apart. Welcome back to The Explainer. Today, we're diving deep into a concept that genuinely sounds like pure science fiction, but it's actually grounded in some of the most insane engineering humanity has ever come up with. The big question is, instead of fighting that extreme, fiery, hypersonic environment, what if you could actually use it? What if you could take that glowing, superheated air and turn it into the moving parts of your engine? That is the wild promise of magnetohydrodynamics. So here is our game plan for today. We're going to start with breaking the heat barrier, unpack how MHD actually works, check out something called the Ajax energy bypass, look at how we might cancel the sonic boom, survive planetary re-entry, and wrap up with the massive engineering hurdles standing in our way. All right, let's jump right into section 1, breaking the heat barrier and hitting the hypersonic wall. Okay, so when a vehicle pushes past Mach 5, and especially as it creeps up toward Mach 15, it hits a literal thermodynamic wall. The vehicle creates what's known as a stagnation point, right at its nose and leading edges. That's where all that compression and friction generate extreme thermal energy. Conventional scramjets and rockets, they suffer terribly here. They have incredibly narrow design parameters, and the sheer heat stops them from sustaining hypersonic cruise. Why? Because these solid, moving mechanical parts of traditional engines simply can't survive the thermal ablation. They just burn up. And that is exactly why you can't just book a commercial flight to Tokyo at Mach 15 right now. So, how in the world do we fix this? Well, that brings us to section 2. Magnetohydrodynamics, or MHD, and this wild idea of the plasma rotor. The insane engineering solution here is to just get rid of the mechanical parts entirely. See, when air heats up to these crazy hypersonic extremes, it becomes ionized. It turns into a plasma, which means it can now conduct electricity. Magnetohydrodynamics takes advantage of something called the Lorentz force. Essentially, when you run an electric current through a magnetic field inside this plasma, you create a volumetric force. It's like a sci-fi linear motor. But the actual physical, superheated air flowing around your vehicle becomes your engine's moving rotor. If you take a look at the schematic we've got here, you can visualize this invisible force at work. Notice the flow velocity of the ionized air moving across the surface. By using electrodes to pass a current density, you can see that red arrow there, through a magnetic field pointing up and away, you generate the Lorentz force. By perfectly controlling that magnetic field and the current, you are literally pushing and pulling hypersonic flow. And the craziest part? You're doing it without ever touching the air with a physical mechanical surface. And that foundational physics leads us directly to our third section, the Ajax energy bypass, which honestly looks a lot like we're just cheating thermodynamics. Now, I know this sounds like modern theory, but it's not. These are actual declassified documents from the 1990s detailing a Soviet project called Ajax, or Ajax. Researchers over at the Hypersonic Systems Research Institute in St. Petersburg were analyzing what they dubbed a magnetoplasma chemical engine. They basically wanted to use MHD to completely flip how a scramjet engine processes high-speed air. Let's break down step by step how this energy bypass actually pulls this off. First, you ionize the incoming air right at the engine inlet. Second, you use an MHD generator to extract electrical energy from that incredibly fast, super hot air. Believe it or not, this actually slows the air down and cools it so your engine doesn't melt. Third, this newly pre-cooled air enters the scramjet, where fuel is injected and combusted. And finally, the electrical energy you harvested upfront at the inlet is bypassed to the back of the engine, powering an MHD accelerator that blasts the exhaust out at even higher velocities. When you run the cycle analyses on this, it shows specific impulse gains of up to 50% over a standard scramjet. That is a massive leap in efficiency. But beyond just thrust, MHD has another huge trick up its sleeve. Let's move to section 4, canceling the sonic boom and creating a wall of silence. Building on that Lorentz force we talked about, we can solve another notorious aerospace problem. You see, a sonic boom happens because characteristic Mach lines in the fluid accumulate and intersect, creating a massive pressure wave. But by using an electromagnetic force field to actively accelerate the fluid where shocks normally form, and then decelerate it in the expansion regions, you physically straighten out those Mach lines. You are actively preventing those lines from intersecting near the vehicle's wall entirely. The difference here is absolutely staggering. We all know a traditional sonic boom is this thunderous, disruptive shockwave. It shatters windows, and it's the whole reason supersonic flight over land is so heavily restricted. But with an MHD flow control system, you modify that shock structure so heavily that it degrades into what's called an MHD sonic thump. The sources literally describe it as sounding like a car door closing. If we can master this, it revolutionizes commercial flight forever, opening the door for quiet, supersonic travel right over land. But hey, we don't have to just stay in Earth's atmosphere. Section 5 takes us to space, surviving planetary reentry with magnetic heat shields. NASA is heavily looking into MHD for spacecraft plunging into the atmospheres of planets like Mars and Neptune. And the capabilities of these recessed MHD patches are mind-blowing. Think about this. Just a single 1 square meter patch can generate 200 kilonewtons of force for lift and drag. That means you can steer a spacecraft hurtling through an atmosphere without any flaps or moving parts. At the same time, it's harvesting energy from atmospheric friction to actively charge the onboard batteries. But the absolute coolest part? By decelerating the plasma in front of the vehicle, it pushes the bow shock farther away. This acts as an active thermal protection system, reducing the blistering heat at the leading edge by a massive 50%. Okay, so this all sounds perfect, right? Well, it's time for a reality check in Section 6, Ultimate Engineering Hurdles. As insane as this engineering is, the physical constraints holding it back are just as massive. To get a truly meaningful MHD effect in high-speed flights, you need magnetic fields of roughly 4 to 10 Tesla. Generating fields that strong requires massive, super heavy, superconducting magnets, and that carries a severe weight penalty for any aircraft. Plus, we have this brutal, almost comical thermal incompatibility. These magnets require cryogenic cooling to stay superconducting, yet they have to operate mere inches away from plasma that's burning at over 2,000 Kelvin. Oh, and if the air isn't hot enough to naturally ionize on its own, you have to use onboard electron beams to create the plasma yourself, which draws an astronomical amount of power. A U.S. Defense Intelligence reference document actually summarized this dilemma perfectly. They stated that these flight devices remain quite impractical, quote, unless a breakthrough in magnet and materials technologies occurs, resulting in ultra-lightweight magnets with roughly 10 Tesla. The physics are absolutely sound. The mathematics, they work perfectly, but our material science needs a monumental breakthrough to turn these heavy, power-hungry systems into practical, lightweight flight hardware. And that leaves us with a truly fascinating question to wrap up this explainer. We already have the exact blueprint for flying silently at Mach 15. We know how to survive the fiery plunge into alien atmospheres using nothing but invisible electromagnetic fields. So, as material science and superconductivity rapidly advance day by day, how long until humanity finally achieves the impossible and masters the magnetic skies? Thanks for hanging out with me to explore the insane engineering of magnetohydrodynamics. Keep questioning, keep learning, and I'll catch you in the next explainer.